All right, so we're going to finish up section 6.5, which is on solving right triangles. Okay, so yesterday we learned all the trig functions in terms of the words opposite, adjacent, and hypotenuse. Today we'll use those to find how long sides are and how big angles are. Right, so when they ask you to solve a triangle, that's exactly what I just said. Okay, they're asking you to find out how long is each side, how big is each angle. But in order to do that, they have to make sure they give you enough information. They always have to give you 3 pieces of information. Okay, one piece of information they're going to give you, it's a right triangle. Okay, so what does that tell you? Okay, you have a 90. Okay, so that's one piece of information that's common to everything, but we need 2 more things. Yeah?
The 2 other angles are complementary.
Okay, yep, the other angles are going to be complementary because they all add up to 180. But does anybody know what other information? There's actually 2 cases they could give you. Yep?
Also the fact that the other 2 angles are acute.
Yep, there'll always be acute, but that's just a fact about a triangle. So they got to tell us something specific. They actually have to give us some numbers.
You need at least one side length?
Yes, for both cases you have to have at least one side. So they could give you a side and an angle. Okay, they could do that. Or they could give you a side and what else? A side. Okay, in addition to the 90. All right, so we'll look at one example of each case. Okay, keep in mind the Pythagorean theorem. Okay, we might be able to use that to help us. Also, the fact that all the angles in a triangle add up to 180. Okay, that's important. Okay, any questions? All right, let's just look at 2 examples. As we go through them, we're going to stick with using sine, cosine, or tangent. It's not that you can't use secant, cosecant, and cotangent, but why do you think I'm sticking with these 3?
Do you actually have those buttons?
Yeah, we have buttons for all these on the calculator. All right, so that makes it a little easier. Okay, and the way you figure out which one of these you want to use, okay, you have to look at the side they give you and the side you want to know relative to an angle. Okay, so let's look at an example. All right, so they're giving me alpha is 20 and A is 12.3. Okay, what do you think the first thing I'm going to do with this information is? Before I even really start to use calculators and that kind of stuff, yeah?
Draw a picture.
Yeah, we're just going to make a picture. Again, none of our pictures are going to be to scale. The only thing you have to make sure when you draw it is A is across from alpha. And what's the other side we're going to label? B is across from beta. And then C is always your hypotenuse. Okay? Doesn't matter how you draw it other than what I just said. So I'm going to put alpha there, which means A is there, B is there, beta has to go there, and C has to go there. Right, so there's my 3 pieces of information, the 90, the 20 degree, and the 12.3. Yes?
You already know what beta is.
Yeah.
Interior angles.
Right. Yep. We can find beta quickly. What I'll do is I'll make a table and just write everything in it. Okay, just to organize all our information. And then we have the right angle, which is always 90. All right, I'm just going to put boxes around what we need to find. C, B, beta. Okay, A we already know, 12.3. Alpha, let's see, yep, we know that is 20. Right, so Autumn, you were saying we can get beta right away. How come?
Because there's a theorem saying that all 3 angles of a triangle add up to 180.
Yep, all the angles have to add up to 180, so if you know 2, you automatically know the third one, just subtract from 180. So what is beta? 70. All right, so now I have a choice. as I find B and C, I could use either alpha or I could use beta. Which angle should I use?
Alpha,
I should. Why should I stick with alpha?
because you might have messed up on your B calculator, but you don't know for sure that alpha is one.
Right. Okay, if we made a mistake finding beta and we use that to find other things, then other things are going to be wrong. If we go back to what was given, at least we know that's correct. All right, so that's going to be my reference point. Okay, I'm going to use the 20-degree angle. I'm going to use the side that I know. And I'm going to try to find one of the two sides I don't know. We could do either one. Let's just start with B. Okay, now we just have to figure out the names of these two sides using the terms opposite, adjacent, or hypotenuse. Okay, what's 12.3? Opposite. How about B? Adjacent. Now think which one of the three trig functions has opposite and adjacent in it? Tangent. So we're going to set up our equation. Tangent of, what's my angle?
Alpha.
Alpha, which is 20, equals. Okay. What side is opposite?
3.
And adjacent? B. Okay. Now we just solved that equation. Okay, our first step, we can multiply both sides by B, just to get rid of that fraction. And then we can finish by dividing by the tangent of 20. So we get 12.3 and divide by tangent 20. So if you look at it, what really ended up happening is the B and the tangent 20, they just switch places. Okay, if you want to see the reason why, this is why. Multiply by B and then divide by tangent 20. Questions on that?
Do you want us to simplify it or leave it
Yeah.
exact?
Yeah. So now we'll just simplify. Okay, 12.3 divided by, we're going to make sure we're in degrees. I'll fix that. So go to degrees. And we get 33 point, let's just say 794. 33.794. Now, because I have A and B, what could I do to get C? I could do the Pythagorean theorem. But why would that be a bad idea? Potentially a bad idea. Brian?
Because then you'd have to use a number that you can solve for, which is 33.794, which might not exactly be accurate. You'd be better off just doing another one of the trig functions with the alpha that's given and the x.
Yeah. So one reason we might not want to use B is, first of all, if we made a mistake, then if we use it, C is also going to be wrong. Second reason, even if we didn't make a mistake, that's not the exact answer. Right? That's rounded. If you use something that's rounded, it's going to mess up C and make that even more rounded. Okay. So what I'm going to do is just go back to the two pieces of information I was given, the 20, the 12.3, and now I'm going to find C. Okay, so we're focused on everything that's in red. Okay, anybody see which trig function I would use this time? Sine. I know the opposite. That's the side I know. The side I want to know, hypotenuse. Out of these three trig functions, the only ones that have opposite and hypotenuse is sine. Okay, so what's my equation? Sine of 20 degrees equals 12.3 over C. And what can I do with sine 20 and C? Yeah, basically they just switch places. Okay, so if you're not sure why, just multiply each side by C. That gets rid of your fraction. And then you're going to have to divide by sine 20. And now we'll just type it in. If you type the last one in on your calculator, you can just go like that. Bring up the last thing. And just change that to sine if you want to do it that way. All right, so we get about 35.963. Okay, in any triangle, you should always be able to add two sides together, and they should be bigger than the third side. So I'm just checking that. If we add A and B, looks bigger than C. B and C added is definitely bigger than A. Okay, that looks good. Biggest side should always be across from the biggest angle. Smallest side across from the smallest angle. Okay, so things look reasonable here. Any questions on that one? Now, if you had extra time, okay, what you could do on the test is you could check this with Pythagorean theorem. It's probably not going to come out exact because you rounded, but try 12.3 squared plus 33.794 squared. So a squared plus b squared should equal 35.963 squared. Yeah, so we got 0.32 and then 0.34. Again, that's because of the rounding. Notice, even rounding to 3 decimal places, a squared plus b squared equaling c squared, it's not even accurate to the second decimal place. Okay, so I'm just showing you that even a little rounding affects the answer pretty quickly. Okay. Any questions on that? Okay, so that's the case where they give you a side and an angle to start. All right, so let's look at the case where they give you two sides. Okay, in this one they didn't tell you which side is A and which side is B. It doesn't really matter. Okay, if you want to call that A, call that B, that's fine. If you want to switch them, that's fine. It's just going to switch alpha and beta.
It says the hypotenuse in one
12.7
leg.
would be C.
Oh, thank you. The hypotenuse in one leg of a right triangle. Yeah.
So 12 is the hypotenuse.
So yeah, I'm sorry.
Yeah.
So that does make a difference. No, 6.1, I know that's not the hypotenuse. And again, so for 6.1, I meant to say it doesn't matter if you call that A or B. Okay? But the hypotenuse, generally, you should keep that as C. All right. So let's just make our diagram and see what happens. Okay, so my hypotenuse is 12.7. B is 6.1. So I'll put beta across from B. I'll put A as the bottom side. And I'm going to put alpha across from A. Okay, and the directions are to solve. Okay, so we have 3 things we need to find. A, alpha, and beta. All right, so I'm just going to make a table just to organize my, my answers. So 12.7, 6.1, and the right angle. What can't we do this time that we could last time?
Solve for the other angle median.
Yeah, we can't get the other angle right away, but we can do something else this time that we couldn't do last time. Yeah? Yeah, why is it okay? Why do you think I'm okay with using it this time?
You have 2 exact values.
Yeah, these were given, we know they're exact, so everything we're plugging in is an exact answer that was given, so that's fine. Okay, so A squared plus B squared equals C squared. Okay, so on the type when they give you 2 sides, this is how you generally start, okay, with Pythagorean theorem. So A squared, and you know what, I'm not even going to round anything till the very end. How would I move 6.1 squared to the other side? Just subtract it. And get A by itself, how would I do that? Square root. Okay, and that is how I'm going to type it in. So I don't round anything off. Okay, till the last step. Right, so let's see what we got. So we've got the square root of 12.7 squared minus 6.1 6.1 squared. Okay, so that side is 11.139. Any questions on that? All right, now let's see. Do you want to get alpha or beta next? It doesn't matter. Beta, okay, let's get beta. So we're going to get beta. And now should I use, I have choices. I need to use two of these sides. Which two should I use? Use the given ones, yep. Use the 6.1 and the 12.7. Okay, so now we just have to figure out which trig function based on the names of these sides relative to this angle. Sine. We know opposite, we know hypotenuse. Okay? So the sine of beta equals opposite over hypotenuse. Okay, now what? Yeah?
You could just do inverse sine of 6.1 divided by 12.7 equals beta.
Yeah, so now that's something we gotta take a look at. All right, so we could have used a different angle, but we did, let's see, beta. Sine beta equals 6.1 over 12.7. Okay, so what we're trying to do here is cancel out sine. We're going to do cosine in a second. Okay, you guys chose to do the other one first, which that's fine. Okay, so to cancel out a trig function like sine, cosine, or tangent, that's where we use what's called inverse trig. Okay, so this is the first time we've seen these symbols, okay, in this class. Okay, basically, if you think of any function you have in math, there's always an opposite of it. Okay, square root, square, add, subtract. In calculus, you have differentiate, integrate. Okay, they undo each other. Well, sine, what undoes it? Inverse sine. Okay, it's like it cancels it out. Inverse sine is written as sine with a -1 up high. That -1 is not an exponent. Okay, which is kind of confusing because if you put any other number there, it is an exponent. Okay, but when you put a -1, it's kind of a special case that we're saying, hey, this is the symbol for inverse sine. That's all it is. An older way of writing it, you might see in some books, is arc sine, arc cosine, or arc tangent. It means exactly the same thing. Okay, just an older way of writing inverse sine. All right, so now, whenever we use inverse trig, whatever we do on the left, we have to do on the right. Okay, so Brian, what did you say to do here?
I said inverse sine of 6.1 divided by 12.7.
Yeah, so we're going to take the inverse sine of what's on the left. Okay, and I want you to understand I'm not multiplying by inverse sine. Okay? Just like if I have this. You wouldn't say multiply each side by square root. You'd just say take the square root of both sides. Okay, I didn't multiply the square root times x squared. I'm taking it. Okay, I'm plugging this into the square root. Right? Same thing here. I'm going to plug all of this into inverse sine. It's going to cause those to cancel. Okay, and on the right, just try to squeeze that in. I'm going to take the inverse sine of 6.1 over 12.7. Okay, and then that will give me beta. All right, anybody know how you type in inverse sine on the calculator? Yeah, second sine. 6.1 divided by 12.7. Okay, so that's 28.706, and what's my label on that? Degrees. Okay, I'm going to put the answer down here. Okay, so one thing, make sure you understand is anytime you type in inverse sine and hit enter, that number that you're getting right there is an angle. That's the only time you use inverse trig, if you want to find an angle. Okay, so in fact, I'm gonna write that. Usually we use regular trig when we already know the angle. Okay, but we use inverse trig when we don't. Okay? All right, so now if we were running out of time and it was a test, technically you know two angles. You could add them up and subtract from 180. But if beta is wrong, then alpha would be wrong as well. Okay, so let's find alpha by focusing on those three. Okay, which trig function would I use this time? Right?
Cosine?
Yeah, I know the adjacent, I know the hypotenuse. So out of these three, pick the one that's going to have adjacent and hypotenuse. Okay, so I'm going to write cosine, and can you finish it, Brian?
Cosine of alpha equals 6.1 divided by 12.7.
Good, 6.1 over 12.7. And to cancel out cosine, what will I do?
Inverse cosine.
Do the inverse cosine. Okay, take the inverse cosine of each side. So that cancels. And we get the inverse cosine of 6.1 over 12.7. 61.294?
Yep.
Okay.
Why did I know your answer?
You didn't get that?
No.
Is yours in radians, Dr. Reese?
Yeah, that could be it.
Trust me, that's what happened to me last week.
I
John,
have
we had to do
Okay, one way I can check this, just make sure these,
39.40.
okay, make sure these add up to 90.
So it's 90.
Okay, or, 89.99, pretty close to it. So yeah, that's another way to check it. I know this answer is right. These added up to 90, so it's got to be correct. Okay, again, biggest angle, cross from the biggest side, smallest angle with the smallest side. Add up any two sides, and they should be bigger than the third. If that doesn't happen, then something's not right. Okay, so any question on the two-side case or using inverse trig? Did we have to use inverse trig on this one?
No.
No, because you didn't need to solve for an angle. Okay, you could do that just by adding and subtracting from 180. Okay, so you only use inverse trig when you're given two sides. That's the only time. Right. Does anybody need to see another one with the two-side case? It'd be exactly like this one. Okay, the only difference is here they're giving you, actually they're still giving you a leg and a hypotenuse, so it's almost the same thing. Right. All right, so next thing I want to do is just kind of tie in what we learned, and I did this yesterday a little bit, with unit circle. Okay, this small circle in the middle, that's a circle of radius 1. Okay, and then around it I drew a bigger circle. Now, we learned that whether your triangle is that size, which, put that there, or this size, does that affect when you're finding the trig functions? No, because the angles, if you match them up, all the angles are the same. Okay, it doesn't matter the size of the triangle you use. So we should be able to extend unit circle trig to a triangle of any size. Okay? But before we do that, we just have to remember, and we did this yesterday, what are my trig functions on the unit circle? What's sine?
Sine is y.
Sine is y, yep. And cosine?
X.
X.
And tangent?
Y over X.
And what do we do to get the next three?
1 over y, 1 over x.
Yeah, just flip
And
it.
x over y.
Okay, so that's a review. Okay, those are our trig functions on the unit circle. Well, there's a couple ways we can extend it to a circle that's not a radius of 1, we're just going to use what we know about right triangles to do that. Okay, that's the easiest and quickest way to do it. Okay, so I'm going to look at that triangle in red. Okay, that's the big triangle. It's just easier to look at over here. Okay, here's theta. How long is this bottom side based on that coordinate?
X.
Yeah, it's x. Go over x and then go up
Y.
y. And what did I mark the radius as on the big circle?
R.
R. Okay, now just use what we know about right triangles, right? And we're going to write this using unit circle, or non-unit circle. Okay, what would the sine of theta be in that diagram? It'd be y over r. How about the cosine?
X over
X over r. And how about the tangent?
Y over X.
Y over x, that one actually stays the same. Okay, so those are our trig functions on a unit circle, a non-unit circle. This time the circle can be a radius of r. It can be anything you want. Now, if you let r be 1, what would y over r turn into? Just y. How about cosine if you let r be 1? Just x. Okay? So those definitions that I gave you before, the y, the x, and the y over x, they were really a specific case of these, where I just said I'm going to let r be 1. Okay? And then, of course, if you flip them, 1 over y, 1 over x. Since r is not involved with tangent or cotangent, those stay the same. Okay? So these are your 6 trig functions in terms of a circle with radius r. So now there's 3 things you need to find. If they give you a point, you got x, you got y, but what else do you need in order to use these definitions? Yeah, you got to have r. How would you get r? Let's just go back and look at it. Yeah, this we know x and we know y. Just use the Pythagorean theorem to get r. So this is going to be what? Square root of 13. Three squared is 9. 2 squared is 4. 9 plus 4 is 13. Take the square root. And that's really it. That's the only extra step to doing your trig. If you want to think of it as a circle with x's and y's, you just have to find r first. Okay? But it's really the same thing as opposite and adjacent. It's just you're thinking of it as a graph rather than just as a side in a triangle. All right, so let's do, what's the sine of theta?
3 over square root of 13, which is 3 squared root of 13 over 13.
Yep, and I'll fix that. Cosine theta?
2 squared root of 13 over 13.
13 over 13. And tangent of theta?
3 over 5.
And, yep, 2. How about my cosecant?
Square root of 13 over 13.
Yep, that's r over y. My secant? Good, square root of 13 over 2. And my cotangent? Yep, 2/3. And I already had all those written. So, okay. Well, anyway, that's the answers. Now, at any point here, did we actually find theta? No. We found the sine of theta, the cosine of theta. Probably said this before, but it's kind of like if you met somebody and you just describe a bunch of things about them without actually even knowing their name. Okay, that's what we just did. Described a bunch of things about this angle, but we don't even know what its size is. Okay? Any one of these pieces of information is really enough to find the size of the angle. Okay? When I have a choice of which piece of information to use, I generally use sine. Okay? So I'm just going to write this over here. So my goal here is to get theta by itself. Yeah, just use inverse sine. If you wanted to use inverse cosine, that wouldn't be wrong. You could do that. But then you'd have to use 2 square root 13 over 13. Okay, so inverse sine. Okay, and of course, this is just an estimate. So for that second, inverse sine, 3 square root 13 over 13. Okay, that should be okay on my calculator. Anybody else get that? 56.31? Anyone else? Brian, did you get that?
Oh, I didn't put it into my calculator.
Just want to make sure we're right. Okay, so somebody else try it. Just make sure you get the same thing. Okay. Thank you. And that's our angle. Now, what we have to be careful of sometimes is the quadrant we're in. Well, based on that point, I know the quadrant I'm in. Okay. Point 23 is in which quadrant?
1,
And all angles in quadrant 1 have to be between what?
0, 9.
They always have to be between 0 and 90. And that's exactly what that is. Okay, so any questions on that one? So we knew it was acute. But we can do the same thing if we're in quadrants 2, 3, or 4. And that's the first step. Okay, this 56.31, that's the first thing you have to find. Okay, but what would you do if, let's say, you're in quadrant 2. Okay, and let's do the same thing. Let's just call this point, what was it, 2, 3 before? Let's make it -2, 3. And let's put theta right there. What's the sine of theta if I use that point?
Three over
3 over
That's square root of
square root of 13. How does that compare to the one we just did? Right. It's the same sine value, but am I in the same quadrant?
No.
No. So my angle this time is really this. When you do inverse sine, all you're finding is this. Okay, which in quadrant 1 is fine. That green thing it's the same. But what do you think you'd have to do in quadrant 2 to find that red arrow? If you knew this part right here.
It'd be 180 minus that part.
Yeah. You do 180 minus the thing in green here. We call that the reference angle. Okay, so it's 180 minus the part in green gives you the part in red. Okay, so that's what you have to do in quadrant 2. How about if I was in quadrant 3, okay, and I knew this angle, and what I'm really trying to find is that big arc in red. What would I do there? Yeah?
You just add 180 to it because otherwise you'd be trying to subtract 180 and it'd be negative angle.
Right. So if you know what's in green, oops. Okay, if you know what's, say this part right here is 40 degrees. Well, you've already gone halfway around, plus this part could be 40 more, so you just add 40 and 180. And that gives you the big arc, big curve in red. Okay, and then the fourth quadrant, it ends up being 360 minus your reference angle. And you could go through the reason why and sketch it out. Okay, but the first step is always to do the absolute value of the inverse sine, because we don't want to think of an angle as negative here. Okay, we always want our reference angle to be positive. All right, so you find that first. If you're in quadrant 1, you're done. If you're in quadrant 2, tells you what to do. Quadrant 3, quadrant 4. If they want this in radians, what would you use instead of 180? Pi. And instead of 360? 2 pi. So we can do this in radians or degrees. All right, is this the same as the one I just did? No, this is 2 negative 3. Okay, so they want me to find the angle where this point is on its terminal side. Okay, which quadrant am I going to be in? 4. Okay, think I'm going right 2, down 3. So if you were going to sketch this as an angle, that's the initial side, that's the terminal side. We're trying to find that angle. So the first thing I'm going to do is find my reference angle, and then we'll look up what we do from there. Okay, so let's make a triangle out of this. There's my triangle. One side is 2 units. The other side is 3 units. Okay, this is my reference angle. The reference angle is always the one near the origin. Okay? Whatever quadrant you're in, it's the one near the origin. Okay. And you know what? Let's see. Let's call this, let's call it theta 1. Hey, I'm going to call it theta 1 because I already used theta in the problem as the final answer. So let's find this first, and then we'll find theta. Okay, which trig function are we going to use here? Or which one did I recommend to usually use? Yeah, I recommended always using inverse sine, and that's going to give you your reference angle. Okay? So that means if you have to find the hypotenuse, find it, and then go from there. Okay. What's my hypotenuse? Yeah, it's the same as the other one, square root of 13. Okay, so theta 1 is going to be the inverse sine of what? Don't worry about cleaning it up. We're just going to type it into the calculator.
3 squared is 13.
Okay, yeah, if you want to clean it up, that's nice. But you don't have to, okay? Because if we're just going to type it in, this is not a final answer to a problem. We're about to get an answer in a second. Okay, so I'm okay with you doing this as long as this is not a final answer, and it's not. Okay, and what do we get for theta?
56.
Yeah, we just did that earlier. 56.310. But this time it's just my reference angle. Okay. So how would I find the angle in red? Take my reference angle and subtract it from 360. Okay, so that big arc in red is 303.69 degrees. Okay, and on a test, it'll always be clear if I want you to just find the reference angle or find the actual angle where the terminal side, between the initial side and the terminal side. Most times I'm going to want the angle between initial and terminal. Okay, so any question on that? Okay, does anyone need me to practice one in each quadrant? Okay, finding the reference angle is the same every time. It's just, do you do 180 minus it, 180 plus it, or 360 minus? Just follow those directions. But stick with the absolute value of inverse sine. Okay? Just stick with doing it that way. Otherwise, you might get a negative angle, or you might get confused. All right. Let's see. So for the quadrantal angles, these are kind of a special case where the coordinates all have a 0 in them. Whether you go, 0 could be some value, comma, 0. Okay, go right some amount, but don't go up and down. This one, for 90, you never go left and right, you just go up a certain amount. For 180, we just go left. And then we don't go up and down. And then for 270, you just go down. So that would be like,
0 to 0.
yeah. Again, A, B, C, and D are some numbers. So since you have a 0 involved, okay, what can happen here? We could get undefined. Okay, we could get 1. Okay, coming up a lot. So you might be like, well, how could you get 1? Well, if you think of this as a triangle, it's kind of weird, but if you think of this side as a triangle, that's almost like your hypotenuse, okay? And it's the same as A, right? I generally don't think of it that way, all right? So these are special cases, okay? If it helps, think of the unit circle definitions, okay? Like sine of 0, think of sine as the y value, okay? Think of cosine as the x value. Tangent would be y divided by x. Okay. Right, so any questions on those? Okay, so 0, 90, 180, and 270. If you type sine, cosine, tangent, secant, cosecant, or cotangent, the answer is always one of those 4 things. Always. Okay, so any questions on the second half of 6.5? All right. So the homework tonight's on the same page as last night, 361, 25 to 34, 40 to 42, 45, on 49 to 53, just odds, and 57 and 61. We'll take a look at that tomorrow. Okay, we'll go over it, and that'll be it for this week.